This video is on exponent rules or exponent properties. The first property we're going to be looking at is called the product property. The product property is when you are multiplying, you multiply when two bases are the same. What you're going to do is write the base and add the exponents. So again, it's when product means to multiply. So it's when two bases are the same and being multiplied. So if we look at this example right here, this is the general rule of this. We have x raised to the m power times x raised to the n power. Because these two bases are the same, they are both x, and they are being multiplied to each other, that means we can add the exponents together. So if you see, we write the same base, we do not change the base at all, and then we put the exponent of m plus the exponent of n. Now, if they are numbers, then we can actually add those together. So let's use that rule to do these examples. First example is x to the third power times x to the eighth power. Since these are both the same bases of x and they are being multiplied to each other, we can keep the x, we can keep the base the same. So we'll have x raised to the, we'll take our exponent of 3 plus our exponent of 8. Then we simplify this. 3 plus 8 is in fact 11, so we can rewrite this as x raised to the 11th power. And this is our final answer. This has been simplified. We're not solving because we're not solving for x. We are just combining our terms that we can. On the next problem, we have 2 raised to the fourth power times 2 raised to the second power. Now, these have bases of numbers, but they follow the exact same rule. It's whenever the two bases are the same, that's what we're looking at. So the base of 2 and the base of 2 have the same base, and the two pieces, the two expressions, are being multiplied. So this would be the product rule. In order to use this product rule, we write the base again. So the base is 2, that does not change. And then we take our exponents and we add them together. So we would have 4 plus 2, which this becomes the base of 2 raised to the power of 6. Now, on the first example, we had x raised to the 11th power, and we could not do anything else with that because we had a variable and a number. On example B, we have a number as the base and a number as the exponent. What that means is that we can actually simplify this and say what 2 to the 6th power is. We do not have to leave it as an exponent in exponential form. We can put this as 2 to the 6th is 64, because that would be 2 times 2 times 2 times 2 times 2 times 2. That's what 2 to the 6th power means. So I'm going to make a little note about this problem, and it's because there are no variables in this problem. So since there are no variables, we can simplify completely the numbers. So we simplify completely the numbers. That's why we did not leave it as 2 to the 6th power. That is not a wrong answer, but it is not fully simplified because 2 to the 6th is 64. Our next example has a little bit more to it, but we have a parenthesis set times a parenthesis set. Parentheses times parentheses is a product, so we do see that we are multiplying two pieces. But we have to look at the bases that are the same. So we need to really focus on which pieces are the same. We have a base of x, and we also have a base of x. So these are being multiplied to each other. X squared is being multiplied to x cubed because the multiplication is in between them. So we really have x squared times x cubed. Those are the same bases. So since those are the same bases, we write the base and add those exponents. So I'm going to write this out in purple. This would be the same base of x, and we'd have the exponent of 2 plus the exponent of 3. But we'll notice that there is another piece of the expression in here. We also have a base of y. We have a y in the first set of parentheses and a y in the second set of parentheses. Those are also the same bases as each other. So this would be a y and a y. We have y times y to the fourth. So since they're the same bases and being multiplied, we write the base, which is the y, and then we add the exponents. Well, what are the exponents? Notice there is no exponent written on this first y, but invisible math tells us that there is in fact one y here. If this was y to the 0 power, that means that there would be no y's there, but we do have a y. So that would be y to the first, plus the other exponent is the 4. These are our two letters that we have, and they are two separate bases, but we still match the bases to each other. Now we just need to simplify this. And since there are variables and numbers, we do not turn it into just a single number. We turn it into an expression of numbers and letters. So the x turns into x raised to the 5th, 2 plus 3 is 5, and then y raised to the 5th, 1 plus 4. Now this is x to the 5th times y to the 5th. All of these were multiplied together. There was no addition symbol, there was no subtraction symbol, there was no division. This was all multiplication. So our answers are still multiplied to each other. So this was the product rule. Again, the product rule is when it's multiplying when the two bases are the same.